today's session, and my today's presentation topic is BIM-enabled sustainability assessment of design for manufacture and assembly. So here's a brief introduction about myself. I'm currently a third-year PhD candidate in the Robotics School of Sustainable Construction at UCL, and my PhD thesis is about how the FMA has been implemented in complex building systems and how the traditional design process has been modified or changed in order to support building system integration. Previously, I was trained as an architect during my undergraduate study in Zhang University of Science and Technology. Later, I furthered my study in UCL at my current school as a master's student. And before my PhD here, I worked 1 year as a research assistant in the University of Hong Kong. So let's get into today's topic. There's a brief introduction about the definition of DFMA. So design for manufacture and assembly is a design approach that focuses on ease of manufacture and the efficiency of assembly. By simplifying the design of a product, it's possible to manufacture and assemble it more efficiently in the minimum time and at a lower cost. This definition is from this conventional definition is from the construction and manufacturing industry. And this concept has been developed nearly 100 years since World War II. DFMA was regarded as a design approach to facilitate the weapon production. And with the urbanization process, more people will live in the city in the future, which brings huge pressure to the low productivity in the AEC industry. So just recently, many governments, such as Hong Kong, Singapore, and the United Kingdom, have published related policies and documents to promote this emerging concept and try to locate DFMA into the AEC industry. So we therefore conducted a systematic literature review, try to understand the current studies of DFMA in the AEC industry. We found that one type of research is about design optimization based on DFMA. Whereas studies developed techniques to optimize the design, and we found that many data analysis techniques are based on a type of method named multi-criteria decision-making. Besides, we found that BIM is often used together with DFMA, and people expect to use BIM to facilitate the ability of DFMA in different ways. We then reviewed the combination of MCDM and BIM in the AEC industry. We found that sustainability is a major application domain of these two techniques combination. This result drives me to think about if I can use the combination of these two techniques to facilitate the sustainability of DFMA, especially for the sustainability assessment. So I further explored the study of BIM-enabled MCDM in the AEC industry. We found that AHP and TOPSIS are two most commonly used methods. So later, we generate a framework by reviewing related paper. This framework shows that commonly used processing flow of BIM-enabled MCDM studies. It starts from multi-criteria generation and then go to the building data collection. Finally, it will be processed by a MCDM technique for a specific application domain. Currently, we find that knowledge contribution or research innovation are mainly focused on three parts. The first part is that some studies try to use advanced MCDM techniques. They may also incorporate some optimization models or empirical-based models, which facilitates the methodology contribution. The second is data collection innovation. Some studies try to integrate emerging databases to building data sets, such as GIS, digital twin, and city information modeling. In this way, they can enrich the BIM model's data. Besides, a few studies try to innovate the criteria database by using some advanced techniques such as machine learning to generate multi-criteria based on company's data rather than generating multi-criteria from expert opinion or literature review. The third is that some studies apply MCDM to a new application domain. So this study's contribution related to innovative research questions. Thus, we found that with the development and the implementation of DFMA, there is no study about the sustainability of assessment of DFMA. We then established our topic is BIM-enabled sustainability assessment of DFMA, which locates on the intersection of industrialization, digitalization, and sustainability. We then try to use the most commonly used combination, which is fuzzy AHP topics to deal with our question. AHP is a widely used method with MCDM to facilitate the selection among various alternatives. The AHP method has been used to weight each criterion by decision makers or experts, and then to generate priorities by constructing a hierarchy. The fuzzy AHP methodology has further developed the conventional AHP method by integrating fuzzy set theory to analyze uncertainty judgment of experts, such as using natural language. And topics is one of the useful MCDM methods and can be combined with AHP. According to this technique, the best alternative would be the one that is nearest to the positive ideal solution and farthest from the negative ideal solution. The positive ideal solution is a solution that maximizes the benefit criteria and minimizes the cost criteria, whereas the negative ideal solution maximizes the cost criteria and minimizes the benefit criteria. In this study, topics method is used for determining the final ranking of the facade design. So here's the case selection. A case was in China was used to validate the method we proposed. This project locates and the owner for this project, they want to renovate the facade system, and the existing structure would be kept. So only the facade will be changed. The facade system is more like a product system. The architect designs the facade and the various components will be manufactured and assembled on site. So we thought it would be a typical case for our proposed technical validation. So totally there are 8 design options for this project. So they share the same building footprint, building plan, and the structure system. And finally, we decided to use three design options in this company paper. We discussed with the principal architect of this project to identify the 3 most suitable options. And we then identify 11 multi-criteria based on expert interviews and the literature review, such as reduce the number of modes, reduce number of part counts, reduce the standardized number and the type of connectors, assembly, error tolerance, lightened material and components, environmentally friendly materials, low operation energy consumption, environmentally friendly building forms, environmentally friendly indoor space, reduced fragile parts, easy replacement of building components and the materials. And finally, this data set was input into fuzzy AHP top 6 method to show that facade design option 3 has best sustainability performance in terms of DFMA. So in the future study, we will further develop this conference paper from 3 perspectives, including to generate solid multi-criteria based on more data and BIM, to use advanced MCDM techniques, and to enrich the case data set. So here are some related studies which place a foundation for today's presentation. So finally, thank you for your listening, and this is my presentation, and welcome to any comments or